I'm Elliotte Harold. We're going to be talking about effective unit testing. I hope everyone can now, looks good, so we can see the slides. So I'm now going to jump in. And this is not going to be an introductory talk. I'm here today to talk about unit testing, but I'm not going to tell you how to write a setup method, what a fixture is, the various different kinds of asserts, or anything like that. I'm going to say, given that hopefully, I don't know how large the audience is, I can't see you at this point, but I hope there are a lot of you, and I hope everyone is doing test-driven development and everyone is writing automated tests. And whatever language you're using, I primarily use Java. I'm a Java developer, but 90% of what I'm saying applies equally well to Python, to Go, to C++, to Kotlin, to whatever language you happen to be working in. Given that you're writing unit tests, given that you're writing your tests first and doing test-driven development, how do we do that most effectively? How do we get the largest bang for our buck? And how do we improve our development process through testing? Because one of the interesting things about unit testing, test-driven development, is that it's not just about testing. It's also about the process of software development. It's about writing code faster with fewer bugs that ships and satisfies the customer's needs. Now, before I delve deeper in, I'm going to give you a brief background on myself. Currently, I'm tech lead for Google's Cloud Tools for Eclipse project. Among other things at Google, also the cloud open source Java effort and diamond dependencies mitigation efforts. Currently, Cloud Tools for Eclipse has about 70% test coverage, which is a little lower than I'm comfortable with. Prior to working at Google, I developed an open source library called XOM for processing XML with Java. That was a greenfield project, and it came up with about 99% test coverage and was almost entirely written test first. At this point, the only things that aren't tested in XOM are a very few branches of things that really aren't reachable code but have to be in there because they're exceptions that must be caught or things like that. I'm also the current maintainer of the Jackson XPath library. I'm a committer on the Apache Maven project, where I've been doing a lot of work lately. I'm the author of a few books. I think the most recent computer book is Java Network Programming. I also write fiction under a variety of different names. And most recently, I've also published a set of principles around dependency management for Java libraries, which you will find at jlbp.dev. That was a joint effort with Garrett Jones, Tomu Suzuki, and several other people. And I hope you will check that out at some point. But today, I'm here specifically to talk about unit testing. So let's delve into that. First question, why do we write unit tests? The answer is really simple, because we want our code to work. I hope that's not a controversial statement, that we want our code to work. There are times when you feel like you've just got to grind out the code, you've got to get something checked in, you've got to get as many lines of code submitted as fast as you can. But ultimately, if the code doesn't do what it's supposed to do, it's not very useful. We're usually not trying to just bang out as many lines of code as we possibly can as quickly as we can. And if you want to get to working code, then there is no faster way I know of than doing test-driven development. And unit tests are a big part of that. Unit tests are also a big part of making sure that the code continues to work as it's modified, as it's changed, as new features are added, as the requirements change down the road. As long as you have a solid test suite that exercises all your various code paths, then if you accidentally break something, you're going to know about it fairly early, and that's really, really useful. It is much easier to fix a bug when the test fails as soon as you introduce the bug than when you discover the bug in production 2 months, 3 months down the line. So writing unit tests and other forms of tests, which we'll also talk about, integration tests, functional tests, and so forth, really helps us to keep the code working once we've got it in reasonable shape in the first place. I also write unit tests because I want to develop faster. And I find that when I write unit tests and when I write my test first, even if I'm writing twice as much lines of code, I'm still getting to the end sooner than I would if I don't write any tests at all. I was recently on a genuine emergency project, as in every day mattered, and every day sooner we shipped was really going to make a difference to real people. It was related to COVID-19, and I'll perhaps talk about that, the whole project, some other time. But one of the first questions one of the developers asked was, well, can we skip writing tests to speed us up? And my answer was, are you crazy? You write the tests because they help you write it faster. You write the tests because you're going to get to the end sooner. That's important. And you also write the tests because I make mistakes, you make mistakes. Every developer I've ever known, no matter how smart, is making mistakes all the time. And the tests catch them sooner where they're quick and easy to fix. I find even the simplest methods that you imagine, well, you couldn't possibly have a mistake in a method that just says set name, and it has one argument that's a string, and then it goes this.name equal name. Well, actually, yes, I know from brutal experience that methods that simple can and do have bugs, at least the ones I write do. And if I write the tests first and make sure that the model code makes the test pass, then they'll still have bugs, but I'll find the bugs sooner and I'll fix them sooner. So that's why I write unit tests, to make my code better, to make it work. Now, for unit tests in particular, I'm not talking about integration tests here. I'll get to that. I'm going to begin with what I call the fundamental principle of unit testing. This is true in any language, in any framework, whether you're using TestNG or JUnit in Java, whether you're using something else in C++ or Kotlin. What does a test do? It verifies that a known fixed input produces a known fixed output. For example, if you're testing a square root method, it's going to verify that the square root of 9 is 3, that the square root of 4 is 2, that the square root of 1 is 1, and that the square root of -1, well, that depends on exactly whether your square root method works with doubles or complex numbers or throws exceptions. And that's one of the sorts of things that a test-driven approach can get you. It can show you where maybe you're not fully thinking out the API, you don't have all the requirements in place to begin with. When you're writing your unit tests, this is really important. This is something I see coming up a lot in interview problems. Start in the middle of the road. Take the square root method again. The first test I write for a method like that is for 9. Is the square root of 9 3? Or is the square root of 9 -3? Or is it some list of both things? That seems like a really obvious answer. But digging into it, you see that it's not, that there are actually several questions to be asked. And by writing the test, you force yourself to answer those questions even before you write the model code that takes a square root and returns a value. You know what your requirements are and that maybe you haven't set them out so well. I often find people, new graduates in particular, sometimes in interviews, will try to start testing by saying, okay, well, what are the extreme cases? What's the square root of a negative number? What's the square root of nan? What's the square root of the largest possible integer, or something like that? But honestly, that's an incredibly optimistic approach. You need to test the edge conditions. You need to test the fence posts. But I would not start by assuming that my basic code for handling the obvious and easy cases is working either. At least 50% of the time, the first version of the code for the middle of the road that I write is in fact not working, and it is also buggy. So start there. Verify that a known fixed input produces a known fixed output. That's the core of all automated and unit testing. Now, there are going to be times that are trickier than just the square root. So, for example, what if you don't know the correct output? You're testing something that's not as simple as a square root. Well, there are a couple of cases. If it's a deterministic answer, you might be able to write a characterization test, which is verify what the current output is, and then write a test that reproduces that. For example, over the last couple of years, I've spent a lot of time looking at Maven dependency trees. And they can be very complicated if you look at just even a basic project like XOM or JDOM and say, what is its dependency tree? And then we want to verify that our code produces that same dependency tree. To do that, we will often write code to find the dependency tree and then turn that code into a test. That's sometimes okay. There are other times when the problem is fuzzy or not perfectly defined. For example, I've also worked on some code for clustering problems where you have a number of points in space and you need to divide them up into, say these points belong to group A and those points belong to group B based on how close they are to each other. And sometimes if there aren't any clear boundaries between the groups of points, the answers aren't obvious, and there might be a point in the middle that could go into group A and that would be okay, or it could go into group B and that would be okay. How do you test that? Well, one way to test it is you change your input data so it's really, really clear so that there's strong division between the two groups of points. So instead of testing the fuzzy case, you make a case with really, really clear answers and you test that instead. So that's sometimes useful. But regardless of what the problem is, ask yourself, what's the input? What's the output? Send the input into your program, usually into a single method or function. Sometimes it's slightly more complicated than that. Get the output back out. And then you'll be in good shape. It is important for this to work to make sure that the input and output are really, really clear and that they're not dependent on anything that changes. So, for example, never use random input in any sort of automated test. You might use that in fuzz testing. You can use that sometimes in exploratory testing, to try and wash out parts of the system where you haven't looked. But if you do that, you need to be very careful about saving your input so you can use the exact same input in the future and reproduce it. For unit testing, for integration testing, you should always have fixed input values. And it's not just randomness that we're trying to avoid. Don't use named constants from the model code. They might not have the right values. Prefer literal strings and numbers. Try not to access the network. Networks are flaky. You don't want a test that fails just because Soda-type's Maven server is suddenly returning 403s, forbidden HTTP codes to your unit test. Don't ask me how I know that one. Sometimes it's okay to read input data from the file system if you include it in the source code repository, but even so, it's less reliable than just code that's directly in the test cases themselves. So try to avoid the file system as well. If you have code that depends on time with a clock, for example, you're going to need to inject the clock. You're going to need to know what time your test runs. I have absolutely seen tests and model code that worked most of the time and failed across the New Year's boundary or failed across the leap year boundary, sometimes in production with very bad effects. So you've got to watch out for that. Your tests should not rely on the system clock. They should use fake clocks that, set the time, speed of light, gravitational constant of the universe, whatever you're trying to pull in from the outside world, that should be part of your input. Now, that's the first principle, the fundamental principle of unit testing. Second, slightly less fundamental principle of unit testing, but almost as important. Write your tests first. Okay? It's because test-driven development is unit testing. It's not just about testing. If you're a tester, you may not have the opportunity to do this. You may be given the code, it already exists. I understand. If you're, though, a software developer, if you're the programmer writing it first, please start with the tests, because test-first development creates better APIs because you think about things from the perspective of the user of the code, the client of the code, not from the perspective of the code itself. It hides the implementation. It supports the good object-oriented principle of data encapsulation, and avoids exposing a lot of internal implementation details. When you depend on a public published API for your tests are also less brittle. They are not as tightly coupled to the model code. You can refactor far more easily. You can, for example, easily change from an array list to a linked list implementation or vice versa, to cite a very trivial example. If you only depend on the public API. So that's test first is also going to make better tests. I'm going to give everyone in the audience a second to look at this code. Here's an alleged test, and there is a bug in the test. It is a very subtle bug. So take a look at the code, think about it, and see, do you see the bug? Do you see why the test is not testing what it's supposed to test? I mean, it's supposed to be very basic. It creates a list. It adds something to a list. It makes sure that the list has size 1. Really straightforward test. But it's broken. Now, normally I'd ask for people to raise their hands, but since we're all virtual, I'm going to go ahead and tell you. I will say this. The first time I wrote this example, I went back the next morning and I couldn't see the bug in the test, even though I deliberately put it there. If, on the other hand, you run the test, and you run the test in a test-first way where you expect the test to fail, you will find the bug immediately. I'll give you another hint. The bug only exists in JUnit 4. It does not exist in JUnit 3. There's a missing test annotation on the test add method. So this test does not actually test anything. And if you wrote it before writing the code, then you would first thing you do is you make sure the test fails. And when the test doesn't fail, because there's really no test here, then oops, there's a problem. So that's another reason to write our tests first and to make sure they fail before we write the model code that makes them pass. It's really important. Otherwise, you're not testing things you think you are. Third fundamental principle of unit tests. This is getting less important as we go. The first is more important than the second. The second is more important than the third, but they're all important. Unit means one. Each test, by which I mean each test method, should test exactly one thing. Best practice, one way of thinking about this, is in a test method, there's exactly one assert. There may be a lot of code to set up the test. There may be a lot of code to tear down the test, but you're only asserting one thing per method. If you need to share setup code between multiple tests, share it in a fixture. Don't put it all into the same method. When you see many different things being tested in one method, that's okay as long as everything passes, but as soon as one of those tests fails, it gets much harder to debug than if the tests are cleanly separated from each other. It's also the case that a single failure can hide other failures that might also be shown at the same time if the tests were more clearly separated. So if you need to share setup, do it in a fixture. That's a setup method in JUnit. It can be other things in other frameworks, not in the same method. And if it helps, use many different test classes per model class. You don't have to stuff all your tests for foo into foo test. That's not necessary. Unit also means independent, and this is really important. So all your tests should be independent of each other. Now, there are a lot of ways this can fail. First of all, tests can and do run in any order. There's no guarantee that the first test in a test class will be run first. So you want to make sure that one test does not leave anything in place that the other test depends on or depends on not to be true. Tests in some test runners, in some test frameworks, not in all test runners, not all the time, may be run in parallel in multiple threads. So if you've got any thread synchronization issues in your test or in your model code, it can show up. And that can be a really hard one to debug because, like everything else involving multi-threaded code, it will throw, it can be flaky. It may pass once and then fail the next time you run it. And it can be very hard to debug. Tests in general should not interfere with each other. If one test is setting up a data structure, you want to make sure that the next test gets a clean version of the data structure, not a modified version of the data structure. In JUnit and a lot of other frameworks, that happens almost automatically as long as you don't have shared static state. Instant state is usually safe, surprisingly. You also need to watch out for shared global state in the model code. This can be a problem. Or in the environment. There are, I came across a case, I'll show you a little later, I think, or perhaps in Q&A, just this morning, where somebody was setting up a cloud storage bucket, an actual directory, essentially, in Google Cloud Storage, not a mock, but they were creating a real bucket in the Google Cloud Storage server, and then they were using it in multiple tests. And that caused problems because what one test wrote into the bucket was still there when the next test began running. So be careful about that sort of thing. For similar reasons, avoid conditional logic in your tests. If, here's an example, if x greater than 5, assert one thing, else assert something else. If you're seeing if statements with asserts in them in a test, that's a real code smell. I would, in a code review, if I came across something like this, if I come across any if block in a test, I pay really close attention to it because it means probably something is not happening in the way it should. So that is a concern. Okay, thread safety. I already mentioned thread safety is tricky. Watch out for synchronization, semaphores, special data structures, special thread safe types like atomic long, atomic Boolean, and so forth. If you have any of these in your test code, as opposed to your model code, in the model code, you need these. In the test code, you probably shouldn't need them, and if you're seeing them, watch out. Don't share any data between tests. Instance fields are usually not shared because every test will typically run with a new clean object. If you have, test foo and test bar in the same test class, they are run in two different objects. But watch out for non-constant static fields in your tests. Those are huge code smell for tests. Here is an example. This is actually the case I mentioned earlier, where this is from this morning. And what happened, and I'm not signed in here, so it's not going to show me quite the way I wanted. Let's see, the pull request. Okay, this is even going to web page is being tricky on me. So let's see. But here's the actual bug. It fails because it actually shared the Google Cloud Storage bucket. Okay, I'm not going to go into the details of the code there. I'll try and bring it up better in Q&A if people are interested. As I said earlier, best practice, one assert per test method, share setup in a fixture. Now, two little known perhaps least known facts about unit testing. So, number one, I've said this several times already, tests do not share instance data. These two tests both pass. Notice, oops, can't select there. A list test object has a list field. It's just a simple array list. The test add method adds one value to the list, a string, and asserts that the size is 1. Test add 2 elements adds 2 elements to the field and asserts that the size is 2. Both of these methods pass. Both of these tests are correct, regardless of which order they're run in, because the test runner is not going to use the same list test object to run test add that it uses to run test add 2 elements. Take a second to think about that one if it's not clear. This is something that often surprises people, that I often catch in code reviews again and again and again. But you don't need to create all your objects in a setup method to avoid the tests interfering with each other. Now, 2, you can have many test classes per model class. You don't have to put everything for foo into foo test. Generally speaking, you want to separate your tests by setup rather than by putting everything in, every test for the foo class into a single class. Okay, speed. Normally at this point, I would stop here for intermediate questions, but I can't really hear or see anybody, so I really hope everybody is seeing me. But let's talk about the speed of tests, because this is really important for getting a good iterative development cycle where you move things through very quickly and you can just write code very fast. Any single test should probably run in a second or less. Ideally, if a test method takes more than a second, it probably should be an integration test, not a unit test. It should probably be separated into a different test target, a different Maven module, something like that, so that you don't have to run it as part of your general development cycle. The complete suite of all your unit tests should run in a minute or less, so that check-ins are very quick, so that when you make a change, you very quickly know whether you broke anything or not, or whether all the tests pass or not. If your test suite takes more than a minute to run, consider whether you can break it up and take the slow tests and pull them out into a completely separate okay, and this is for development. And then finally, fail fast. If something's going to break, you want it to break as soon as possible, but you can run the slowest tests last. And I'll show you an example of this if we can. Here's a change I made in Cloud Tools for Eclipse a couple of years ago. And you notice all I did is line 81 here, which is the integration tests. These are some particularly long-running tests. I took them out of line 81 in front of where they were ran before, things like the test for the welcome screen or tests for data flow, and I moved them to the end because they're slow. That's it. But what that means is that if any of these things fail, I find out sooner. Generally, put your faster running tests earlier in the lists of things you run. Let's go back up and let's present. Oops. Okay, I'm going to have to get back to the right window. Yeah, we're all in a new world here. Okay, now, having said a lot about unit tests, I will admit freely that not all tests need to be or should be unit tests. There is a lot of place for other kinds of tests in the world. There are a lot of places for different kinds of things. Integration tests generally cover very large parts of code at once. They tend to be more functional oriented and less focused on does this method work and more on does the system do what it is supposed to do. They can cover many lines of code with very little effort. For example, in my current project, we have a lot of integration tests that do things like search Maven, a particular well-known Maven dependency tree for particular problems that we know are there. And that's going through hundreds of lines of code my team has written and probably thousands of lines of code in the Apache Maven project. And all those are being tested by one single test that's looking for one particular thing. On the other hand, though, if something does go wrong and one of these breaks, it's much harder to debug because the test itself is not very focused. Now, other advantages of integration tests, they often catch errors in the interfaces between classes that unit tests miss, where one class makes an assumption about what it's supposed to pass to another class, and that assumption is violated. You won't find that with a unit test because the test has a different assumption about the interface than the unit class does. Integration tests can even catch changes in the external environment. App Engine Plugins Core, a library that we use for cloud tools for Eclipse and some other products, recently had some integration tests that noticed that someone at Google, I still don't know who, had renamed all the icons for all the cloud products that we were depending on. And therefore, suddenly a bunch of links broke. That's the sort of thing that an integration test might catch. A unit test is never going to see because a unit test, ideally, is never going out to the real world and talking to the real environment. You need both unit and integration tests to have good test coverage, to have a lot of confidence in your product. They're both important. They both have their place. They should both be automated, though, and they should be able to be run without human intervention. Which brings us to the next subject, manual tests. I know there are some people in the audience who spend a lot of time, pounding on products, trying to make them break. That's really fun work, in my opinion, although the software developers may not like you very much because you always find bugs. Exploratory testing is important. It almost always, I should probably get rid of the almost, always uncovers unexpected bugs because there are always bugs you aren't counting on and you're not looking for. But when you find a new bug, an unknown, don't just file and fix it. There should always be an automated test that verifies that the bug exists and that the fix works. Depending on how teams are structured, depending on individual developer experience, it might be the tester who writes the automated test, it might be the programmer, they might be the same person or different people. That varies a lot from team to team and company to company and project to project. But what's important here is that you get automated tests for bugs, not just an issue in an issue tracker and a patch that allegedly fixes it. Because if there isn't a test, how do you know it was really fixed? This helps to avoid regressions, because if you don't do this, we've learned from hard experience that the tests will come, the bugs will reappear, probably sooner rather than later. And it also makes it much easier to cut a release. I have been on projects where, we wanted to have a 1-week release cycle, but it took 2 weeks to execute to just go through a long list of manual tests. So that's not a good place to be, and you want to automate your tests to the extent possible. Now, a few general principles for all kinds of tests that you might encounter: unit, integration, functional, exploratory, manual. At least for automated tests. This is a big one, and I really want to talk now to anybody in the audience who's ever thinking of writing test software themselves. What at Google we might call a software engineering test. Passing tests should produce no output, or at most, a simple message, everything passed. There should never be any questions to whether a test passed. If it passed, it's green. In Japan, for cultural reasons, it would be blue instead of green. If it failed, it's red. And you might be able to actually use real colors depending on your environment. In Eclipse, for example, you get a nice green bar when the tests pass, and you get a red bar when the tests fail. And that's it. Now, if it failed, yes, you want to get a lot of messages from your failing test to help you debug it. But for passing tests, nothing. If necessary, silence loggers and tests. Silence any output. Just say, yes, the test passed. Maven, I'm afraid, much as I like it, gets this badly wrong. I mean, here I'll show you a test result. Now, this is blue. This is in the Jenkins continuous integration server. And we can see that this passed. No test result, no failures. So that's all we should have. But in fact, if you, let's see, can I go back here one? Yeah, there we go, back. Let's go. But what does it actually put on the console when that happens? And it's skipping over 2.5 megabytes of junk that's just not being shown on this web page, but Maven's outputting it. It's got a lot of info. It's downloading these jar artifacts. I don't care about any of that. Nobody does. So when the test passes, it should not produce output other than a simple message that test passed. And when the test fails, it still shouldn't produce this much output because this makes it very hard to find the small parts that you might actually care about, amidst all this log junk. As developers, we've gotten way too comfortable with logging things no one's ever going to read. And it just makes it hard to find the real log messages we actually care about. And that's a subject perhaps for another talk or Q&A session if you like. Failing tests definitely do need to produce clearer output. So, clear, unambiguous error messages. They should clearly identify what failed and where it failed. One way that is surprisingly useful to help that is to rotate your test data. I don't mean random test data or arbitrary test data, but in every test method, choose something different. So for example, if you're using the name John in one test, use the name Mikhail in the next test, or use the name Yevgeny in the third test. It doesn't, that will help you find the code that actually has an error. It's a simple technique, but it's really, really effective. Ints, you don't just set everything to 3, use 33, 1117, etc. So you can see which test is failing and why and when. If you need to test collections, lists, sets, hash tables, maps, that sort of thing, I'll just give a quick shout out to the Truth Library from the Google Commons team and the Guava project. It gives you much better assertion messages and makes these things easier to test for people working in Java. One of the few Java-specific points I'm going to make in this talk. Okay, flakiness. This is a big one. This is something you have to watch out for. Flakiness is when sometimes a test passes and sometimes it fails. And you need to work really, really hard to avoid this. If you find you have flaky tests for whatever reason, fix them. It's important because flaky tests cause people not to trust the test framework. They cause developers to ignore real failures. And that eliminates a lot of the benefits of tests. Why might you have flaky tests? Already mentioned time dependence, network availability, explicit randomness. If you ever see somebody putting a java.util.random or secure random or random.h in C into a test code, please stop them, please. Multi-threading can be a source of flakiness. Model code can sometimes be flaky. This is where things get tricky. You might have a method that sometimes returns one value for a certain input and sometimes returns a different value depending on external conditions like time. So that's something to watch out for. If tests are interdependent, if they depend on the order in which you run them. Bad test infrastructure is a problem. I've been struggling with this in the Apache Maven project lately because, the Jenkins servers can start failing for reasons that have nothing to do with our own code. And then you've got to file a ticket and get someone to fix them. Those are painful. So try and have solid test infrastructure. System skew, if you make assumptions about the underlying operating system, like that the line separator is a line feed, might not be true on Windows or Mac. And then there's undefined behavior, certainly in languages like C or C++, where floating point round off or integer width, or the default character set, can change from one system to the next. Okay, data encapsulation. Nothing I'm saying about test-driven development obviates any of the normal good principles of object-oriented programming. Data encapsulation is the most basic. If at all possible, write your test to test the public published API. Try not to access the internal, private, or non-public parts of your classes. This will make your tests a lot less fragile and a lot less brittle. One common complaint about tests is that it makes evolving code too hard because the tests are too coupled to internal implementation. And the solution to that is don't couple them to the internal implementation, couple them to the public API that you're willing to commit to, if you possibly can. Don't make methods public or non-private just for the purposes of testing. This also gives you some benefits for detecting code that is unused. When I was working on XOM, I often found that if I couldn't test a particular branch of an if statement, for example, through the public API, chances were that branch wasn't actually reachable and I could simply delete it. That was really eye-opening. Debugging. The tester has found a bug, they've reported it, you don't know what's happened, how do you fix it? Well, even before you know exactly where in the code the bug resides, if at all possible, try to write a failing test that reproduces the bug. If the test passes, and surprisingly often it's going to pass, then the bug probably isn't what you think it is, or there are other factors in play that you need to consider when you're, before you're debugging. And then if you have a test that exposes the bug and that fails, then you can proceed to make changes to the model code that fix the bug. Same story for refactoring. If you want to change the code, ask yourself, do the tests fail? Break the code. Make sure that you have sufficient test coverage, because refactoring, even if it isn't supposed to, can break code. Here's an example. This is from Cloud Tools for Eclipse a couple of years ago. There was somebody, I don't remember which developer, wanted to consolidate some create folders methods we had in different parts of our code. It was duplicate code. There was a little similar and a little different, and it was a good idea fundamentally. But what I noticed when I looked at that was that we didn't actually have very good test coverage for this code. And one of the lines that they were going to change, just for the hell of it, I commented it out and I ran the tests. And the test still passed, even if the line was removed. Well, what that says is we're missing a test. So in this case, we had to jump to, we had to first write a better test, and then we were in a position to refactor our code to make it simpler. Another way to approach this is just to look at the code coverage, use a tool like, I'm trying to remember, Cobertura, for example, or Clover. There are a number of other options that will just measure which lines of code are covered by your tests. These are very valuable. I almost always find that if I spend time looking at uncovered code and just writing tests for it that verifies it does what it's supposed to do, I will find new and unknown bugs. So I like code coverage tools. Having perfect 100% line of code coverage does not guarantee that you've tested everything, but it is a necessary, if not sufficient, condition. It is a prerequisite. Okay, some general testing principles, and then I think we'll probably be getting into Q&A shortly. Continuous integration, very useful. Every test, every merge, every PR that you submit, everything you check into your source code repository should automatically run all the tests, and then a red flag should be raised if anything fails. These days, there are many options for this. Jenkins is a very powerful tool in the open source world. You can set up yourself. The Apache project uses it for a lot of their projects. There are commercial options, including Travis, which I use on Cloud Tools for Eclipse and some other repositories I work with. Circle CI is another. Many, many good products out there. Pick one, use it, please. I think a lot of people are now using GitHub Actions to do this sort of thing. That's a relatively recent development. Always be passing. If your test fails, don't check the code in. That's a really important principle. If by accident or malintent, for whatever reason, someone does check in code that breaks the build, roll back first, ask questions later. Don't try and fix the problem. Roll back the PR that was submitted that caused the build to break. And then you're not in an emergency situation. As long as the continuous integration server is red, though, there should be no merges. A red test blocks all merges. There should be no further check-ins until the build is green or blue, as your server may indicate. That's a really important way, a really important practice to make sure that your tests don't get red and stay there. I've certainly seen that happen in organizations that were less test-focused, and it means people stop paying attention to the tests, and you lose all the benefits of having good test coverage. I'd love to do a show of hands on this one, but unfortunately I can't since we're not really in the same room together. If you have an opportunity to use a submit queue, this is still a relatively uncommon thing, please do. A submit queue is where you don't merge and then run the test in this continuous integration server. Rather, first you run the test in the continuous integration server, and the CI server merges the pull request for you if and only if the tests pass. This prevents check-ins on broken builds. It helps keep the build green. It avoids a lot of surprise failures. It's a really, really useful thing that unfortunately is not commonly available. Okay, some final thoughts, and then I think we're going to go to Q&A. I've said this before, the most important thing is write your tests first, make all your tests unambiguous and reproducible. If you do that, you're going to be in better shape than 90% of the developers out there. You're going to be a real coding superhero. You're going to be able to do things you would not believe are possible. Test-driven development is a silver bullet for software development. It's closer to that than anything else I've ever seen, and more decades of doing this than I care to admit. So write your tests first, make the results automated, make them unambiguous, make them reproducible, and you will have a much more pleasant experience with your code. Okay, and I think with that, I'm going to stop the screen sharing. We're going to go to Q&A, so we'll figure out how that's going to work. And I really hope people are out there listening to this, because I have currently no feedback. I'm sort of talking at a screen, so I hope this is working. Okay, Q&A.
That's true. Yes, thank you, Elliotte, for this such a valuable, persuasive talk. We have a number of questions, and
Great.
let me start. You said that one test should have only one assertion. What about matchers like HamCrest and multiple assertions? Do you use them?
You mean like a Fluent Interface where it lines up several assertions at once, contains exactly this dot in order, something like that?
Yeah, something like that, or maybe assert that, and we have a couple of kind of checks after one test.
This is, I'm deliberately pushing a slightly extreme position here. I will say, if for something like contains exactly these elements and then dot in order in Fluent Interface, I consider that basically one assert. You're just you're asserting that a list is equal to some expected value in a way that requires a few methods to set up. That's fine. Another example would be, though, you set up you get, let's say you make a query against a database, probably a bad example, but you run a method, it gives you back an object, and the object has a first name, maybe it's a name object you get back, and the name object has a first name, a middle name, and a last name. So you say assert equals John, name.getFirst, assert equals Fred, name.get middle, assert equals Smith, name.getLast, something like that. That's the case I'm talking about. If you split those up into 3 separate methods, then the middle name can fail, but not hide whether the last name is still passing or failing. That's the case where I think it's very useful to have one basic assert to keep every individual test method laser focused on exactly one thing that can fail or pass.
All right, thank you.
Again, this is more true in unit tests than in integration tests.
Yeah, thank you very much for your answer. And actually, we have a bunch of questions.
Okay, let's go.
The second one is from Anton. Elliotte, how do you test the existing function if it's not pure enough? Let's say it's quite big and it doesn't have any tests at all. Do you refactor it first, or you prefer to write the hard way test? What will you do?
Been there, done that, have the scars. I would say I would write at least one test first. The most basic test I can get away with, just to make sure that I've got the test framework set up, to make sure that it isn't just immediately throwing an exception or just failing completely. I would not do major refactoring without tests in place, and I will put some sort of tests in place. Now, this is where you're probably not going to be able to get perfect unit test coverage. This is where I might write a test. Let's say, for example, I don't know, maybe this big complicated method queries a database and writes a big XML file, for example, or a JSON file, whatever. It writes a big complicated file and it's using lots of logic to do it. I would try and write a unit test, or not a unit test, I tried to write an integration test in that case that compares the output to what we sometimes call golden output. That is, we first run the code, produce the expected output, store it in our source code repository, then write a test that runs the code again with the same input, maybe complicated input, maybe it's not just a single method call, and then verifies that the file you get out the other end is byte per byte identical. Or maybe it's not quite byte per byte identical, maybe it's character per character identical, maybe do some normalization of white space, but just a characterization test that verifies that the behavior hasn't changed without meaning to, without intention. And I would do that before I would try and refactor the code to break it up into something smaller.
Thank you. By the way, I forgot to remind that we will choose the best question, and the winner will receive a book. So in the end, we will need to sum up and choose one of the questions that you like most. And the next one is Elliotte. Why do you recommend not to use synchronization objects in tests? I often use semaphores or something to wait for all threads which I started in my tests.
It's not... Okay, so I'm really curious to know what sort of tests this questioner is writing, that they have these semaphores and they have a lot of synchronization going on. I'm going to assume they're not actually testing multi-threaded code in particular. Testing the correctness of multi-threaded code is its own subject and is incredibly difficult. I'm not sure anybody really has a good answer for that one. But I'm focused more on the general behavior of normal model code, and it should run without external synchronization. It should be correct, I think, without external synchronization as a rule. It may depend a little on the nature of the project you're running, but it's more reliable in general if we can use immutable types if possible, and we can avoid sharing memory between threads. I'm not sure why, other than testing multi-threaded code itself, you would feel the need to share state between two different threads, even if you've got a test runner that is trying to parallelize things to run things faster, to take advantage of a lot of cores, which would be useful. Each test should not share memory with other tests because that way they interfere with each other. And synchronization is basically a way of saying, well, we're going to share memory between these threads, and now let's be really careful about how we do that. And I prefer just not to share the memory between the threads in the first place. That's safer to me and usually possible in a test environment. Model code, very different story. That's not what I'm talking about here. If you've got semaphores in your model code because you've got a multi-threaded program, well, that's hard enough to debug as is. I won't tell you not to do it.
Yeah, good advice. Next one is from Ivan Ponomaryov, and he wonders, what's your opinion about mocks in unit tests? What are the best practices
good one.
of using mocks? Of course, if your supposed mocking is really appropriate.
Right. Very good question, Ivan. I actually had a slide in one draft of this presentation about mocks, but that could almost be a talk of this length on its own. TLDR, use Mockito as a mocking framework in Java. I think it's definitely superior to the other things that are out there these days, so you can avoid easy mock, power mock, JMock, etc. Do not mock value types. So if you have, for example, the other day I actually saw somebody trying to mock an artifact in Maven, which is just a group ID, which is a string, artifact ID, which is a string, and a version number, which is a string. And there is already an artifact class. And you can set the strings and just use that. There's no need to create a mock for a simple value type like that. So mocks are and mocking frameworks are definitely overused. If you can use it as a stub, a fake, a dummy, we can talk about the difference between all those things, fine. Mocks are sometimes useful for helping code to do things that are hard to trigger otherwise. Like, for instance, if you're testing database connection code, you want to see what happens when there's a network error while talking to the database. That's the sort of thing a mock can really help you with. But beware that mocks, especially in older pre-Mockito frameworks, can really tie you to an implementation. Be very careful, especially when you're verifying your mocks, that you're not verifying that they're calling certain methods in certain orders, because that's rarely what you really care about. Mocks can sort of avoid, they can break data encapsulation, and we can end up coupling our tests very tightly to the very, line by line changes in a method. And that makes the code brittle and hard to change. And that's something people don't like about testing. So again, try to write your tests purely through the public API. Try not to over-verify your mocks. That's something Mockito helps with in a way that, say, Easy Mock did not. So that, try to be liberal, to say everything not forbidden is permitted rather than the other way around. You don't want a mock that requires certain methods to be called in a certain order, and if any other method is called at any other time, it's a failure. Focus on the input and the out to the code whether that input is a direct method argument or some external input like a file or network connection, and the output from the method, whether that output comes in the form of a return type or return value, or like a file that is written or network or an output stream that is written to, or something like that. Focus on the input and the output of the methods, and let the mocks just be used for setup and for feeding data into a method in a way that in a real program would come from the external environment, rather than using the mocks as ways that test the implementation happens exactly like it currently does. So yeah, mocks have their place, but they do, used improperly, they can break, they can lead to less agile code.
Yeah, thanks for that detailed answer. And the next question is about tooling also. How can I stop producing logs in passed test only? Is there any tool in Maven or something for that?
I'm not sure I follow that question. How can I stop producing?
Yeah, logs for passed tests. If test will pass it, we don't need to produce so many output. What kind of tools
logs.
can I
okay,
use?
yes.
Yeah. Sorry.
Yeah. Well, one thing you can do is file a bug against your test runner or against the Apache Maven project saying, please don't log so much, or the Maven Surefire plugin more specifically. But very specifically in your tests, some people will, I've seen, set up basically a no logging logger. They create a logger using SLF for J or java.util.logging that accepts all log messages and doesn't print them. And then they configure that as their logger. And you can actually set it as the logger in your setup method in your JUnit test, and then you can set the standard logger back in the teardown method or the after method now in JUnit 4 in your JUnit test. And yeah, so I would definitely, I have spent some time doing that. Logging frameworks do not make it easy enough, in my opinion, to turn them off. There are a few libraries that really want to allow themselves to be silenced. But yeah, in tests, I don't want to see every last log message. You can also try things like saying the log level to debug or log level to off, and sometimes that works and sometimes it doesn't, and depends on the logging framework involved. One problem is that you've probably got libraries that are using multiple logging frameworks that have multiple ways of turning them on and off. It's a rare modern project that isn't pulling in at least 2 different logging frameworks in my experience. I don't know why developers are so fond of writing logging frameworks, but there are. There are half a dozen in the open source world and probably another half a dozen inside Google itself. So.
All right. Yeah, sometimes debug mode helps in such cases, but yeah, it depends. Thank you. The next one is from Dmitry. What do you think about moving of big setup of dependencies in helpers instead of placing them near the text fixtures itself? I guess the question rather than about what kind of things would you recommend to avoid such?
Sure.
Yeah.
Yeah, it's all about duplication of code. So if you, let's say you're setting up, I don't know, a Maven dependency node object, which I just picked because it's something I'm working with in my 80% project almost every day. And I have a particular dependency node I only want to use in one test, then I will create it in that one test method. And generally I will start there. I will start by setting up all the data for any given test in the test method itself, not in a setup method, not in a field. I'll make it a local variable. That's where I start. Now, if I find that The second test I write needs the same object, the same dependency node object, maybe to be specific. Then I will pull it out to a field so I can reuse it in both tests. But I start by making it a local variable, and I only pull it out into a field and set it up in a fixture when I see it's going to be reused. Now, the thing you do have to watch out for there is sometimes you find you have one group of objects that's used by 3 of your tests, another group of objects that's used by 4 of your tests, and a third object that's used by 2 of your tests. And especially if any of those objects are expensive to create, that's when you might want to consider splitting up that whole test case into several test cases, each of which shares its fixture. That can be, yeah.
Yeah, thank you. And the question is, what is your opinion about developing our own framework? It has some benefits, but the problem is new developers have to learn this framework instead of unit JUnit. Can you give us advice? Should we continue to developing our own framework or just switch to regular JUnit?
Switch to regular JUnit, please. You have more important things to do with your time. Even if your framework is 5% better than JUnit, all other things being equal, including developer experience, you will not pay back your investment. JUnit is plenty good enough, and I wouldn't bother with anything else in the Java world. If it were some completely new language, I don't know what the life is like in Kotlin or Swift, but yeah, just use JUnit and save your time for whatever your product is doing that is your unique value, because probably a test framework is not what you're selling or how you're making money or how you're making the world a better place.
Yeah, it's totally true that you have a lot of time to spend on something else rather than building another bicycle, right?
Right.
So,
and I'll say the same thing for a lot of other frameworks, dependency injection frameworks, logging frameworks. Here's a case. I have lost, here's an experiment you do sometime. In your IDE, type string utils and see how many different classes your IDE wants to autocomplete that to. It's usually at least half a dozen. So, yeah.
All right. The next question is kind of tricky. It's from Olga. What's your opinion on using snapshots in unit or even in integration tests? There is on one hand, they can help store large output, but on the other hand, developers can easily update snapshots without even investigation and hide some introduced bugs this way just to make the tests pass. Is that happened in your life?
That's a good one. Thank you, Olga. That is not something any of the projects I've worked on have used as a rule. We do have I call golden files, I guess snapshots in a way for certain output, but it tends to be relatively specific and it tends to be fairly small, relatively speaking. So I would say this, if the snapshot itself can be code reviewed and it's part of the PR and it's possible for a developer to see what changed, that's fine. They can say, oh yeah, maybe what changed is we went from first name, last name to last name, first name in some output. And that was the deliberate intention of this PR. We had a bug that said we have to put last names first now. That's fine. Because the change in the snapshot data will show you that this is addressing the issue. On the other hand, and it will also show you if that wasn't the issue, but just something that happened accidentally, that there's a problem. That does assume you have a good code review process in place to catch and notice such things. But if the snapshot is too large to manually review, or it's in some binary format that can't really be manually reviewed, then I'd be very, very cautious of it.
Oh, sorry. I'm here. If we create a separate test for each assertion, there should be 1,000 of tests in our code base. How do you solve such a problem?
There are thousands of tests in your code base. I mean, source code repositories nowadays don't have problems with that sort of scale. It's use fixtures to share the common setup code. It's just, it's not a problem. Again, the test should run very quickly. The setup should run very quickly. If for some reason the setup for each test is really expensive, like it's taking on the order of seconds just to create the objects, then I'd let it go a little. I wouldn't insist on having a single assert for every one of 1,000 methods. But if the setup is more like a couple of microseconds and all the tests are running in parallel, yeah, that's fine. Computers are really, really fast nowadays, and they can hold a lot of data.
That's actually totally true. We have several minutes left till the end of current session. And as you remember, Michael said that we have to choose one of the kind of best questions that you preferred more. It's hard, and I know. Maybe it's a tough time. I can remind you some of them if you want to.
Well, let's see. There was the log question. There was the question about mocks.
Yeah.
Which was really interesting.
Capturing dependencies.
Right. Snapshots.
Yeah. And maybe last one, which was asked. Yeah.
Okay, am I supposed to pick my favorite? Or?
Yeah, I think so.
Does the audience? I like the mock question. I forget. Sorry, I forget who asked that, but that was an important one, and it's a subject I really didn't address in the talk itself.
All right.
So yeah.
Very nice. By the way, I remind you that we have a discussion zone available after the talk, where you can ask more questions. There are several questions left there, so I guess
cool.
you will have time with our audience, and yeah, feel free to ask questions, please. Thank you very much for your talk. It was very interesting, and I guess it's very useful for most of us, even for developers and even for the testers. Thank you, Michael, for supporting with Q&A session, and hope to see you in discussion zone.